Welcome to the Rory Academy YouTube channel. We share valuable information about power electronics technology and its emerging applications. We have a great announcement to make. Coming soon, we will launch a platform for power electronics technology-based developers. Introducing the brand new www.roryacademy.com. This will be a first online platform where the design, development, and prototyping of power electronics-based systems and products will be learnt and ideas shared through on-demand courses, webinars, tests and evaluation kits developed and sold, and a forum for the curious minds. All our YouTube subscribers will have access to 1-year free membership, which attracts 10% discount on all products. Remember, think deep, think beautifully. Today, we will be examining the structure of the Tesla Model 3 inverter to understand how it is assembled and its key components. Our focus will be on the inverter housing, along with its connectors and connections, specifically related to the placement of the silicon carbide MOSFET devices within the inverter structure. The Tesla Model 3 is a battery electric-powered mid-size sedan with a fastback body style built by Tesla Incorporated, introduced in 2017. The Model 3 was the world's top-selling plug-in electric car for 3 years, from 2018 to 2020. The Model 3 was the first electric car to sell more than 1 million units globally. Let's explore the disassembly of the inverter structure in the Tesla Model 3. We will examine 3 key aspects: the inverter housing and high-voltage connector, the inverter PCB and 3-phase lead terminals, and the inverter PCB alongside the liquid cooling inlet. Now, let's take a closer look at these components. Let's examine the outermost part of the inverter housing, which is primarily made of aluminum. The high-voltage connector links the inverter to the high-voltage battery pack, while the low-voltage connector powers all the low-voltage components of the Tesla Model 3. The coolant passage cover protects the flow of liquid coolant, which helps dissipate heat from the silicon carbide MOSFETs in the inverter. Additionally, there is a coolant inlet through which the liquid coolant enters the coolant passage cover, and a coolant outlet from which the coolant exits the inverter system. Let's open the lid and take a closer look at the inner components of the inverter housing. The high-voltage connector slot and the low-voltage connector are both highlighted. Additionally, the heatsink responsible for dissipating heat from the silicon carbide MOSFETs, along with the housing for these MOSFETs, is also highlighted. The coolant passage cover protects the flow of liquid coolant, which is essential for dissipating heat from the silicon carbide MOSFETs within the inverter. There is a coolant inlet that allows liquid coolant to enter the coolant passage cover, as well as a coolant outlet where the coolant exits the inverter system. Let's examine how the silicon carbide MOSFET module connects to the inverter housing. The module consists of 24 silicon carbide MOSFET devices, with 4 devices connected in parallel for each switching position. Each specially packaged MOSFET device has 5 terminals: the drain, gate, Kelvin source, and an electrically isolated thermal pad. The drain, the high-voltage connection for the parallel devices, is connected to the bus bar. Furthermore, the connections between the upper and lower devices create a 2-level converter, which acts as the output of the inverter linked to the motor windings. The printed circuit board, PCB, is affixed to the top of the silicon carbide MOSFET module and incorporates the necessary gate driver circuitry and controller integrated circuit, IC. Furthermore, a phase LED current sensor is installed on the PCB. The 3-phase LED terminals, which connect to the output of the inverter, are delineated on the PCB. On the underside of the PCB, the inverter housing contains the silicon carbide MOSFET module, the copper busbar, and the DC-link capacitor bank. Let us analyze the connection between the silicon carbide MOSFET module and the inverter housing. This module comprises 24 silicon carbide MOSFET devices, with 4 devices arranged in parallel for each switching position. The accompanying illustration of the 3-phase 2-level converter depicts this configuration. Let's clarify the components of the PCBA in the inverter structure. 1. Power Management Integrated Circuit, IC. 2. Transformer. 3. Optocoupler. 4. Voltage comparator. 5. Pulse width modulation PWM controller. 6. Isolation amplifier. 7. Bleed down resistors. 8. LIN transceiver. 9. 32-bit dual-core microcontroller. 10. Operational amplifier. 11. Multiplexer/demultiplexer. 12. Gate driver ICs, approximately 6 of them. 13. P and N-channel MOSFETs. An intriguing aspect of the Tesla Model 3 inverter structure is that its shape reflects the outline of the United States of America's map. Watch out for the concluding part in the coming weeks. Remember to like, subscribe, and hit the notification bell. Thanks for your support.